let me just remove this. Get rid of the banner here. Ah, there we go. I'm tiny. Wait a second. What? There you go. That's better. Hey. Hey, 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 hey. Hello. Hey, everyone. Thank you for joining. As always, please, first things first, register here. I have actually two streams. This one and just after this one. Something about, one about, Ross. Cool. Hey, Ale, you have to be, Ale guy, you have to be really, really honest with me. It's you who messaged me, right? Because I know someone messaged me and I was like, yeah, I'm going to answer in a few seconds. It happens to me all the time. I don't answer. So yeah, okay, let's do this. Post it. I have to answer that message because I remember I was like, yeah, sure, I'll just answer your message. Answer to Ale. Cool. Okay, post it. Okay, there we go. On my desk. Have to do that today. Okay. Cool. Invited to the first round of interview. Nice. That's really cool. So for anyone who is a little bit curious, I'm also a pod leader at the MLH Fellowship. Spring, so you cannot go into the spring batch anymore, but we have a summer batch, which is tight, or like we pair in with Meta. So it's a production engineering or site reliability engineering fellowship. Really cool. I'll be a pod leader there, so good luck, Ale. And yeah, I hope to see you there. And if you're part of my pod or one of my pods, then I'll be really happy. Cool. Okay, so I share the links. Yes. Really nice. Okay, I hope music is not really loud. Let me just probably 12. There we go. If music is a little bit too loud, just let me know, okay? That'd be pretty sweet. Yeah, that'd be pretty sweet. Cool. Okay. Docker, AI, APIs. Cool stuff. So let's just start. Let's see. I have this. So add to the stage. How does this look? It looks good. Okay, cool. So you might be seeing my whole screen. It's because I'll be using my Linux machine too. So yeah, that's why you're looking at my entire screen. So slideshow to this. What the heck is Docker? Like, okay, I know you've seen Docker's logo. Okay, it's a whale, like with cargo over it. What the heck is that all about? Cool. Docker is a platform for developing, shipping, and running applications inside containers. That's a lot to take in, okay? Just bear with me. Docker is something that developers use to basically ship. It means sending anywhere and running applications inside containers. So we got from Docker to containers. What's a container? Containers are basically lightweight, portable, and ensure consistency across environments. That's what it says. What they really are is, imagine a virtual machine. Now imagine a miniature virtual machine that has only what your application needs for it to run. Let's say, because why not? You build your application in Windows and it has to use, why not, Windows XP? Why? Because it has something that allows your application to run. Okay, I don't know who would build an application only on Windows XP. Could happen, okay? How could you ensure that your application works, let's say on my machine, which is Windows 11, or on my other machine, which is Ubuntu, or in my Mac? Like, how could you make sure that applications run not depending on your operating system? Docker, basically containers, okay? So your containers will mimic a certain environment that allows your application to run without consuming all of your computer's power and resources, basically, okay? So mini virtual machine, whatever it needs for your application to run, that's it, and it lives inside of your system. Okay, and why would you use Docker? Like, it sounds not that easy to use, which, bear with me, we'll make it work. Why would you use Docker? Like, what's the big deal with Docker? Well, first of all, again, you can containerize your applications. You can run it anywhere. You just run a few Docker commands and that's it. It simplifies deployment and scaling. So again, it runs anywhere. Ensures consistency across development, testing, and production. So basically, you know that when you, I don't know, you develop something new, and then, I don't know, you put it on your GitHub, and then you use it on your Raspberry Pi, for example, something IoT based. You make sure that whatever is on your GitHub runs as smooth as in your Raspberry Pi as it ran in your computer. Okay, that's basically it. Again, it could be you have Raspbian in your Raspberry Pi, you have Windows on your machine, it should run as it should, okay, as it ran in your computer. And saves the system resources compared to virtual machines. So again, mini tiny virtual machine. Okay, cool. So that sounds like magic. Like, it's magical. It's crazy. You can make it run anywhere. Okay, cool. Question: is it required for Docker container to only have one app? Nope. You can have more apps like in one container, but you have to be careful there, because let's say that you have traffic, okay? So your container, I don't know, it takes an image. We'll do that. It takes an image. It parses the image, or it uses a neural network to parse the image, and it outputs a result. So let's say that your container does that. At the same time, it's also hosting an app, like your web app. Okay, so we'll do that, but in different containers. But in this case, let's say that we have one container for that. If you have too much traffic, okay, that container could get, like, you can, like, that container can stop working just because it's doing too many things at the same time. So if you're using Docker, try having lots of containers with different things connected to each other. Okay, so you just connect as if you were connected to an application, to, I don't know, a web app. So you can connect through the IP, through sockets, through the ports, basically, and you just have that connection. You don't need to have one thing, like one container per action in your app. I do recommend it. It depends on how you want to manage your load. Okay, which is a good question. There's something called, which we won't look into it today, but it's something called Kubernetes, okay, which is basically container orchestration. It means you can have a bunch of containers, basically copies of the same thing, doing the same thing for different traffic amounts. So, before we go into the Docker file, let's say that you are Meta, okay? So this is how Meta works. Meta, you open facebook.com, okay? So let's say in your country it's 3 a.m. So as Meta, you wouldn't expect to have a lot of traffic. So why have a million containers running at the same time? That just consumes energy, and basically it's not cost effective. What would you do? Then orchestrate, have something that orchestrates your containers and makes sure that, hey, if we have only 100 people looking at facebook.com at 3 a.m., then let's just have 10 containers. Oh, we have now 1,000 people, so let's just have 1,000 containers, and so on, okay? So yeah, that's how orchestration works. We have another question. Does each container have separate virtual identity? Yes, they do. Each container is its own little environment. You can connect stuff to them, but basically you cannot interfere with what's inside of them. You have to, let's say, destroy them, or destroy them, move stuff around, and then put them back online. So basically that's, but they are all, let's say, individual. Cool, good question. Another question: why would you want to run web app on Docker? what is the one thing that will make you dev say we'll need Docker? Okay, that's a really good question. We will do this, and we will do it in the project before after explaining. But imagine, because I run into this big issue. I was using a neural network that ran only on a specific Ubuntu. So again, I had a neural network that ran on TensorFlow only at a specific Ubuntu version. So that TensorFlow version didn't run neither in Windows, nor in Mac, nor in other versions of Ubuntu. It was 19.4, 0.04, something like that. I'm not sure. That project needed to be done because it was my social service project, and I had like 1 month. So it was either training another and creating from scratch another neural network, or having that work. So I use Docker to have only that piece of information, or like that piece of the app running, and the web app running on another container. Because the people who were going to use them were not proficient in programming, so I needed it to be fast and basically portable. So Docker is like, hey, here's the thing, here's the instructions, just do this, and Docker should be running. So that's why you would use Docker for a web app. Now, if it's just a web app, it probably would be counterproductive to use Docker. But inside of your web app, what do you have? If you have something running, like in this case, the neural network, then yeah, you should have Docker. If not, then you can just run your web app as normal, but it depends on where you want to run it too. Okay, good question though, good question. Cool, so Docker is basically a solution to it works on my machine. Yeah, basically, as long as you have Docker, it should work. That's theoretically. Practically, sometimes you have errors, but hey, we just thrive with errors. Cool, okay, so a lot of information there. I bought this juice. It's not that good, but hey, I bought it, so I have to drink it. Is Docker portable? Yes. So basically, you're making teeny tiny versions, or like your app running on teeny tiny things that can run in every single computer that has Docker. So you can download Docker in your Raspberry and run something that also runs on your Windows machine. So yeah, that's what portable is. But yeah, good question. Cool. Okay, so we have a Docker file. What is a Docker file? Okay. Another question, and then I'll just go into the Docker file. Can I have Docker connected to your live web app? Yes, that's what we're going to do. You can have Docker connected to anything as long as they don't interfere with each other, and you make sure that you have every single container has its own port, because you can have, as we will see, like clashing ports. Okay, cool. What's a Docker file? So a Docker file is a text document that has instructions to build a Docker image. That's too much. Let's do that again. A Docker file, okay, it's a file that has instructions that Docker reads to build a Docker image. What the heck is a Docker image? So we went from Docker to containers, and now with a Docker image. What is that all about? A Docker image is basically everything that your app needs is first, you can say, printed as an image, and then it's shipped and created. Okay, it's like the backbone of your app before it's run as a container. Okay, cool. Now, example, how does this look? So it says from Ubuntu, take the latest. Okay, so I want the latest version of Ubuntu, and this is how it's written. It's as easy as this. Run apt-get update, and then as a CMD, which is I want you to run echo hello world. That should work. We won't be doing this one, but something very similar. But this is how a small or like a normal Docker file would look like. You have from, you have run, and you have CMD. You can have other commands too. It's as simple as that. Docker is like magic. Okay. I think I didn't answer this one. Can you have Docker connected to a live web app? Yes. Oh yeah, I did. Yeah, sorry. Cool. Okay. Now you can install Docker from the official page. Okay. To see if the installation is correct, you just run docker run hello world, and we'll see what this does. Okay. And it should download a test image and run inside of a container and just say, hello world, this is Docker. Thanks for downloading, blah, blah, blah. Okay. By the way, Docker is free, but yeah. We'll test the Docker run hello world. Okay. Cool. Okay. We're going into commands, which I'll skip for now. We'll go back to this later. Okay. Cool. Now, I just want to make sure that everyone is on the same page. Okay. We have wireless and wired networks. Okay, so it's easy. Okay, wired networks, something that uses a cable to connect to something else, and they just speak to each other. It can be a Raspberry with an Arduino. It can be your computer with an Arduino. Your computer with your internet modem. It could be your iPad with your Apple Pencil. I don't know. That's how wired connections are. It basically talks to each other connected. We have wireless, which is something that doesn't use cable. Okay, really fun. You can walk with your cell phone around your house watching, I don't know, the stream, and it's not wired, but you have the connection. Now, the bad thing is, if it's wireless, it offers mobility, but it's usually slower. And it's less secure because, as us, we have ears. Our computers have ears too, so to speak. And if a hacker comes and wants to hack your wireless network, they can hear your waves, okay, which is the network basically. So that's like the counter side of wireless networks. Wired networks, limited mobility, but they're pretty fast and they're pretty secure, okay? So depending on where you're at and where you work, you can have only wired, only wireless, depends on like your case. Okay, cool. So if computers have ears that listens to waves, and those waves connect to the internet, and you can watch this stream because of that, how do we know, like, why don't my iPad, my computer, and my cell phone crash? Like, why aren't they running the same thing? They're connected to the same network, and my mom's iPad should be crashing too. It's because every single thing connected to the network has a name. We have two types of names, and what? Okay. Something moved here. Okay, never mind. Where were we? Yeah, okay. We have IP networks. IP addresses, sorry. An IP address is a name given by your internet modem to every single electronic device that is connected to it. What does that mean? It means if you go to your friend's house and you connect to their wireless network, you'll have a different IP address. It means it's only affected by where you are, which is locally, and it's called a local IP address. Okay? But that doesn't make sense. Like, how do you know which computer is yours without having to change that name? You have something called a MAC address. A MAC address, yes, is an address that is embedded in your computer into every single device that can connect to the internet. A MAC address is the name that cannot be changed in your computer, and that's in the board. Okay, so the board that has the ability to connect to the internet, which is wirelessly, okay, your Wi-Fi, that board has a name, and that's the MAC address. Okay, and we'll get to see that in a second. Okay, cool. But this is how an IP looks. Okay, so we have 1 byte or 8 bits for each part of the segment. We have 4 segments. So in the end, we have 32 bits or 4 bytes. Okay, one example could be 192, 164, 11. Actually, let's just take a look at it. Let's see if I remember the Windows command. I'm not sure. Let's see. Cool. So my terminal, good old terminal. What if I do IP config? Ooh, okay. Sorry, it's in Spanish. Yeah, I don't like having my computer in Spanish, but when I bought it, it was like Windows 1, like the version of Windows that only has one language. Why Windows? I don't know. But yeah. Okay. So you can see here, I have this. It says here. It says I just translated IPv4 direction. Okay. This is my IPv4. So this computer is 192.168.100.100. This is the name of my computer in my house. If I go to university, it changes completely. It's a different number. Okay. Here we have a question. It says, "Aren't you doxing yourself with this info?" Nah, it's fine. Cool. Okay, because in the end, you can't like this is all locally. You can try to connect with this here. It won't happen. Like nothing happens. Actually, okay, just do it. If you have Windows machine, do ipconfig. If you have Mac, I think it is IP space adder space show. Try that. You'll probably have the same numbers, and that doesn't mean we're connected to the same network. It actually means that all the way around. Like we're connected to different networks and we have the same name. So yeah. And yeah, I don't know. I hope no one's listening to what I said about Windows. Anyway, here we have something interesting, which is the MAC address, which should be not here. Okay, let's just take a look at it in my Ubuntu machine because I'm just used to Ubuntu. But yeah, for sure, no. Here. Cool. Okay, now what are sockets? Okay, last thing, I promise. Cool. We did. No, please don't. Okay, endpoints. Sockets are endpoints for sending and receiving data over a network. Okay, so we have IP addresses. An IP address is basically the address of a hotel. Okay, cool. Now, we have ports. Ports are basically floors. Okay, floors filled with different rooms. Room number 1, number 2, number 3, number 4, so on. I'm not sure how many ports computer have, but they have a lot of ports. Some ports are reserved. I know that 22, I think port 22 is reserved for email exchange. I hope that's the one, but you get the idea. And the sockets are basically the way of going into different ports. Okay, that's basically what a socket is. Okay, cool. Now, because we're going to program web servers, a little bit of web thingy, so I just wanted to make sure that everyone is on the same page. Okay, nothing more. Let's go to this meet. Okay, so this is my meet, F11 here. Now, why am I connecting to a meet? Because of this thing over here. Again, I use Ubuntu, so let's connect to... Hello? Let's see. Give me a second. And where's the other? Here it is. Okay. Give me a second. Okay, yes, let me just connect to this. Without camera, without anything. Ask to join. That's my other account. Admit. Cool. That's me. Hey. Okay, so. Entire screen. Yeah, why not? Can you all see my screen? Yes. Others may see video differently. That's okay. Let me just probably get rid of spotlight. There we go. That's better. Can I remove this? I'm not sure. Minimize. Yes. There we go. So here. Cool. Let me get my cheat sheet here. Nice. So we have two parts for this project. Okay, the AI part, and we have the Docker part. Let's just start with Docker, and then we'll go to the AI part. Okay. So good old What's this called? What? Visual Studio. Yeah, sorry. Cool. Okay, let's make this work. Let me open my cheat sheet and start coding. So, oh, basically, yeah, wait a second. I just missed something really important, which is, nope, not this one. Let me just open this one, and from here, let me just do this. Okay, cool. So we had here a run hello world, okay? So, not Vim. Yeah, no, Vim. Not if I'm gonna stream. Like, Vim, if I, why would you use Vim if you're going to write Python and stuff? Don't use Vim for that. Use Vim for, I don't know, Bash or something else. By the way, I respect it, but I don't know, it's too much for me. Like the CLI is too much for me. Okay, cool. So, let's test hello world then. It says Docker run hello world. Okay. Cool. Yeah, no, they're not recorded, but I think you can you can find them on YouTube. Yeah, was it YouTube? I think it's on YouTube. You can find them there. Okay, so every single one should be there. But yeah, cool. If not, then just ping me a lot, and you know, I'll be able to help. Yeah, Vim is tricky. Vim is tricky if you're writing lots of stuff. If you're just writing like Bash, that's okay. But if you're writing lots of stuff, nah, it's not friendly at all. Cool. Okay, let's do this. So, Docker, sudo in my case, because yeah, I need permissions. Okay, wait a second. Here we have an interesting question. Are continuous continue to use WebSocket for continuous connections? Yeah, I'm pretty sure like the answer should be yes. I've never had like to differently connect sockets between different containers, but they should be using sockets differently, like different sockets inside of the container and outside. Okay, so because it's not the same port 5000 on your container and port 5000 on your computer. In the end, what we're going to do is breach both of them, so you have to, you know, connect them using WebSockets, but it does it automatically. Okay, cool, nice. So can you see this? Yeah, cool. Okay, so let me do, that's better. That should be better. Cool. Now this should be better. What? Wait a second. There we go. Thank you. Let me just redo this. There we go. Cool. Okay. Now sudo docker run hello world. Let's see what it says. Ooh. Okay, interesting. It says, hello from Docker. This message shows that your installation appears to be working correctly. Basically, everything works as it should. Okay, wait a second, is this muted? Yeah, cool. Okay, so that's basically it. We have Docker running. Now, you can install Docker from the web page. It should take like a few commands. I've never used the Docker version, how do you call this? Like not the command line one, like the other one. I've never used that one before. I find it tricky because I'm used to the command line. So, you know, if you ask like about that one, yeah. How do we install? Okay, yeah, that's it. Docker Desktop. I'm not sure how to use Docker Desktop. I don't even use Git on Visual Studio. I use the CLI. How do we install? Okay, this is a pretty interesting question. Let's just go quickly here. You can do install Docker. There you go. Probably here. Let's see. Yeah, here it is. So learn how to install Docker, and voila, like you should be started. Okay. Here it is. So install Docker, Mac, Windows, or Linux. Okay, it's pretty easy. Okay, cool. Now, good question though. Nice. So let's start. Okay, let's go to Visual Studio. Oh, by the way, we have another command that is sudo docker ps. Docker ps gives us this container ID, image, command, created when, status on off, ports, and names. Okay, so it gives us information about our running containers. I have nothing running, so you can see there's nothing there. Docker Desktop is reserved for enterprise accounts, but I could be wrong. I'm not sure. Again, I've never used it before. I think I installed it once. I don't, because I was trying to learn about Docker and I installed something that I think it was Docker Desktop, but then it's like I didn't know how to use it, so I went to the command line. But yeah, I'm not sure. I'm not sure. Cool. Okay, so that's the first thing. Now, let's start coding. Okay. Again, let me open my cheat sheet, which is GitHub. Cool. Okay, so let's start writing some Python. Okay, Python's cool. Python's easy. Let's do a Flask app. Okay, app.py. If you don't know what Flask is not a dictionary, it's a library for Python to use or to create web apps. Okay, easy to use. Okay, I've used it. I don't know if I would recommend that for like a more professional app, but it definitely helps a lot. Okay, let's just start importing stuff like form. Come on, from Flask, import Flask. Let's import request and import. Oh, come on, and JSONify. There we go. Now let's get something from, an interesting name from. Don't laugh. Pizza class, which we'll create in a second. Okay, import food classification. Cool, and import OS. There we go. Voila. Those are all the imports that we need for this part. Now, let's create the app. This is how you do it. App equals Flask. And under name. Okay. By the way, if you look at long like unders here, it's double. Okay, just careful there because the font is just it's easy to read, but it's not that easy to check that it's one or two underscore here. Okay, cool. Now use decorators here. What? There you go. App.route. Okay, what we will do is basically create a single endpoint, a teeny tiny web page in our container that will listen to us whenever we send an image. Okay, by the way, the project is an AI model that takes images from either pizza or steak and sends you like the answer. Hey, it's a pizza. Or, hey, it's a I don't know, it's a steak. But yeah, that's what it'll do. Okay, cool. So we have to route to an endpoint. An endpoint is basically, okay, so if you're in your computer, or actually I'll show you what an endpoint is. This is how an endpoint looks like. Okay, let's see, F11. This part over here, can you see this? Yeah, this part over here, this is an endpoint. Okay, so that's the endpoint of this call. Okay, cool. Now, question here. Can you share this project after? Yeah, sure. It's on my GitHub, but yeah, I definitely can share it. Cool. Yes. Cool. Okay. So let me just do Control B here, so that looks horrible. We will create an endpoint called classify. Okay, and we'll use the methods. Both. Actually, this one just one. Wait a second. Can I do this? There we go. Post. What does this mean? Okay, this means this thing will only listen to stuff that it sends. It won't render anything. Like, it will visually be nothing, but it will listen to us and send images. Okay, cool. Here we have. Do you typically research libraries to import to your project? Yeah, it depends on what do you want to use. Like, I'm not sure if I get the question correctly, but I just Google like, hey, I don't know, I want to use web apps with Python. And you have like the first 4 options, and it's like, yeah, I'll just take the first one because it's the first one, because everyone does that. And I learned Flask with the production engineering or site reliability engineering fellowship back when I was back in 2021, I was a fellow there, so I learned that there. But yeah, it's like Googling, and the first thing I use it. Like that's what I do. Probably not the best thing, but yeah. Or chat helps me, but don't say that to anyone. Okay, cool. Now, let me just remove the emojis because this takes a little bit of space. That's better. Cool. Okay, so this will listen to stuff. Okay. Let's just create, classify. There we go. And cool. I'll just add the same name because why not? Then I have the image. There we go. Cool. Now, okay. First things first. If we get an image, okay, if we get an image from wherever we're going to send it, not in request dot files, return no image and a sad face, because sad face are sad. Okay, cool. By the way, I have here double this. There you go. Cool. Now, if we don't have an image and we listen to something, we don't want this to crash. So hey, just send something like, hey, I didn't get anything. Okay. Cool. Now, let's ensure that this is downloaded. Download that. There we go. So, image directory equals should be in dot slash. In this case, I'll just name it input images. Okay. Images. Okay. If not, os dot path dot exists. Okay. Image directory. Okay, so if we don't have this directory created, let's just do it, okay? Because if not, computers freak out. Okay. Os did make theirs image directory. There we go. So that should take care of if we don't have it. In this case, we don't. Okay. Cool. Now, that's taken care of. Image file equals request that files and give me the image. Okay. We have to send the image with this keyword from the other side. Okay. Keep that in mind. Cool. Now image path equals this thing over here. Okay. Plus image should be this one. Dot. Cool. So what we're doing here is basically, by the way, let's just do this. That's better. So we're combining the directory of the image plus our image file name. Okay. Just because we want it downloaded. Okay. Cool. Now let's save it. Image file that save where image path. Okay. Cool. Hello. Cool. Hi. Okay. Let's see. Let's continue. Let's process food. Okay. Cool. Now food equals classification here. Should be the same one as here. Yes, it is. Always double check. And prediction equals put that main and image path. Cool. Return a JSONify. And there should be a dictionary here as food. And right. It's a lot, okay? Let me explain that again. We have an endpoint called classify inside of our container, okay? We'll create the Docker file in a second, but this is just like the app that will run inside. It listens, it will listen to something. If image is not in what we want to listen, what I got is not an image. Get out of here, okay? Basically, we have a directory where we want to add our images, okay? If it doesn't exist, create it, okay? We request the file image if we have it, because if not, then this just returns and voila. We save it, we process it, and we return the prediction. We'll process it in another Python, okay? Just bear with me. And as always, if name double equals main, then app.run host, host, there we go. Should be, this means we, as our computer will host it, 0.0.0.0 is localhost, okay? It's not 0000, it's usually 127.0.0.1, if I'm not mistaken, that's localhost. It means this computer. Your computer has the same localhost, okay? Remember, IP addresses, sometimes they are only local, which is yours and mine can be the same, but it won't be in the same range of, or like in the same network. So in the end, they don't interfere with each other, okay? Cool. And let's assign a port here, 5000. Why is that? Actually, no, this should be, no, yeah, this is 5000, yeah. Okay, we assign a port because we want our Docker to be in port 5000, and our app that will be talking to this one in port 8000. We'll see that if we don't change that, the computer will say, hey, something is using 5000, you cannot use it, okay? We'll get to that error in a second. Cool. That's basically it, okay? This is something that listens and computes, okay? Let's do create the computation, okay? Should be pizza class. Oh, actually, no, should be, yeah, should be pizza class. Pizza class.py. Cool. Okay, now, second script. Let me just open it. Oh, okay, this one's going to be a little bit more interesting. More concepts, just let me know if there are some questions, okay? I won't explain lots of TensorFlow here, just because it's not part of the, like going into TensorFlow deeply is not part of the stream. I don't want to waste a lot of time there. Just let me know if there's something that you really don't understand, okay? Cool. So, import OS. OS is always used. I'll do this. I'm not sure if I have to do this. Just I'll do it because I did it and it works. So yeah, this is just to enable some environmental thingies with TensorFlow. Okay. By the way, if you don't know what TensorFlow is, wait a second. TF enable on one DNN OPTS. Wait a second, because this is just weird. And 0. There you go. That should be it. Let me just double check. Enable Odin. Yep, cool. So TensorFlow is a library that Google created to basically use and create neural networks. Okay, it's like PyTorch. PyTorch is Meta's, and TensorFlow is Google's. Okay, cool. Now import TensorFlow STF. Import numpy as np, and from TensorFlow.keras.preprocessing import image as I. Okay, why as I? Because I've used image as image, but because I use pillow, then you know. Cool. Other guy here says we're not actually downloading any packages yet, right? Yeah, no. No. Just Docker. Like that's the only thing. You don't need to download anything more. Okay. Cool. Let's start. A class. Class. Food. Classification. Let me double check if it's the same, because I know myself. I just type with my feet. There you go. Should be it. Def dunder init. Shoot, is it C++ or what? By the way, colon. There we go. And self. Okay, we don't need more than that. Okay. Self.model equals. Now, this is probably the only thing that you'll have to download. Okay. I'll just get rid of this. tf.keres. The models.load model. And this is in my GitHub, which I'll share in a second, but or at the end. Stake that should be keres. Yeah, okay. What are we doing here? Like, what is this? Keres. There we go. Pizza steak keres. That should be it. Yep. This is taking a binary of a trained model, which is a model is a neural network. So it's a neural network that was trained with images of pizza and steak, and I will download the binary. Okay, it's on my GitHub, but this is how you have to do it. I'll share with you how, like the details of how I did this at the end, but yeah, this is what this means. Okay, cool. Now, self.image equals none for now, and self. Will I use masked image? I'm not sure. Let's leave it like this. Wait a second. Sorry, I got like the flu or something from like since yesterday, and I've been coughing a lot, so sorry. Self and then image. Okay, so we need this to the okay. Don't you worry. Let's just get back to that. TensorFlow is a library that was created by Google in order for you to use or create neural networks. Okay, we'll take a look at that like 5 minutes before this stream ends. But basically, you can use neural networks, you can create them, or use neural networks that people have already trained. It can be as popular as YOLO. Okay, so YOLO is you only look once. It has a lot of versions, and it's pretty cool. In this case, this neural network that I created with like following a Udemy course, which I'll share that too. And you can use this neural network too. Okay, so you're not downloading the neural network per se. You're downloading the binary that basically helps you compute the intelligence of the network, if that makes sense. It's like it's just computes the input and output, but it's not like the whole thing. So it's like the binary of that. Okay, but that's what TensorFlow is. Its counterpart, so to speak, which both of them are good, is PyTorch. Okay, so PyTorch is developed by Meta. Google develops TensorFlow. Okay, cool, nice. Image. Let's do this quick. Let's parse the image. Okay. Self.parse. You know, when you're writing a class, it's like, okay, cool. I just have to do something later. This is like the later. Self.parse. Image. There we go. And then let's get the prediction. So if, oh shit, sorry, shoot. Prediction, or let's do pred equals self.model. Oh, come on. Because this computer is smaller than my other computer. So, you know, the keyboard is just weird. Self.model.predict. Cool. So, image. Okay. So, whatever we get, we'll parse it, and then we'll predict with it. And then whatever we predict, computers love numbers. AI is the same thing. It's all numbers. If you see it more human-friendly, it's because they're engineers that do that. It's something like this. If prediction is bigger than or equal to 0.5, it'll mean that we have a steak. Return pizza. Cool. If we probably send an image of a hot dog, it'll probably be a steak in this case. Okay, it's not a neural network that's strong. It just does the job for two things. Okay, let's just leave it there. Cool. Okay, we need this. Okay, So def parse image. What? There we go. Always happens. Remember the self here. If not, it won't work. So we have to resize the image. So images have different size you can find on the internet, okay? We have to resize it so it's the size that the neural network expects, okay? Question, what does a self-parse image do? Wait a second, we'll go there. It basically, so it basically will get the image, resize it, add, it will create an array with the image, and then it will add a batch, okay? So bear with me, I'll go step by step, okay? Cool, so first of all, resize image, okay? So images can be of all sizes. We want something that our neural network will understand, okay? Image equals I, remember I is this thing over here, which is a pre-processing thing from TensorFlow, okay? I dot load image, okay? Actually, it's img, and then it's image. What? Oh, yeah, cool. Wait a second, I just forgot the argument. Image, there we go. Image, and we want to resize it, okay? Target size equals 224 by 224, okay? What is the required size? For this case, 224 by 224, okay? For this case, which I'll show, or I'll share why we have to use 224 by 224, but for this case, it's this, okay? Cool. Now, if we do, good question though. Let's do self that image. We'll rewrite the image equals either img to array. So let's transform our image into an array of numbers. Okay, to array img. Okay, resize it, transform it into an array, and then we'll expand them. Okay, it won't make a lot of sense at first. Okay, and I'll explain why it makes sense. np.expand dims self.image axis equals 0. Okay. Nerd, huh? Take a look at this. Nerd glasses on. This is some math, okay? Ah, here it is. Cool. So, let's see if you can see this. I hope that my filter allows it. Can you see this? No, you can't. It's like nothing. Great. Okay. Let's just use something else. Okay. 1, 2, 3, 4. Okay. Chunky, but it should make the trick, okay? Images have different sizes, okay? We have width, we have height, and we have something else, which is color, okay? RGB, okay? So usually images are, in this case, 224. Let's say 224 by 3, which is RGB, okay? 3 channels, and we will be expanding the dim, which means we'll be adding something else. It won't be a 3D image, it'll be a 4D image. In that 4th dimension, it's something called a batch. A batch is like a group, okay? So this model, this neural network by itself requires this, okay? Why? Because it's not something that I did for it to be user-friendly, okay? So if you use YOLO, that won't happen. It does it for you. In this case, we have to do it, okay? So again, width, height should be 224, 224. We have 3 dimensions, which are not explicit, but RGB. And let's call like the batch, which is like the group, which is 1, okay? Axis 0 means put it in the first place. So it will be 1, 224, 224, 3. Okay, a lot of math. That's what it is, okay? Cool. And we will do something called normalizing, which is putting numbers between 0 and 1, okay, basically. neural networks love that. So, you know, let's just do what they love. Image over equals to, okay, why 255? Because, what was it? Wait a second. What was 255? 255. Wait a second. Why should I normalize with 255? Huh, I don't remember why 255. Wait a second, what? I just wrote this code. 255. Is it because, oh yeah, because RGB, it's from 0 to 255, okay? So we'll have numbers oscillating from 0 to 255, and that's a lot. Yeah, yeah, thank you. So, what we'll do is basically reducing, instead of 0 to 255, which are lots of spikes, 0 to 1. It's easier for neural networks, okay? Thanks, Alagai, always there to save the day. Cool. If name double equals dunder main. Cool. Image equals for now nothing. Food equals food classification, and food dot main. Actually, I think I don't need this one, but I'll just write it down just because. There. Cool. So in this case, I think this was just for debugging, but let's just leave it there. Let me double check everything. Should be good. Okay, cool. Now we have two Pythons. Okay, grayscale. Nope. So in this case, the model doesn't. So it's not that good. So it will use lots of color. I won't do it grayscale because it won't do good. Okay, if it's YOLO, if it's something that other people, which are way better than me, did it, yes. In this case, okay, cool. If it would be grayscale, by the way, it would be 224 by 224 by 1, because it's just one dimension, okay? Grayscale is just from 0 to 1, 0 to 255, I'm not sure. But it's just like one number, not three numbers, or not three channels, okay? Cool. Now, let's go into the interesting part. Docker file. Aha! Okay. See, Visual Studio adds like the little icon here. Docker is not running. I don't care. Thank you, Visual. Nice. So, what do we need for this to run? Okay. Oh, by the way, Aligai asked something here. I'm at TA and my students' projects are making mini Photoshop in C++, so it's pretty fresh in my head. Yeah, no, that's fine. That's fine. Thank you. Thanks for the help. This juice is horrible. I don't know why I bought that. It's horrible. It says on the can, it says gamer, and I was like, yeah, horrible. Cool. Okay. From what do we want it? What do we need for it to run? Easy. Python. Okay. Colon which of what version of Python? 3.9. In this case, /slim. We don't need all Python, just some things from Python, okay? You can research what this means, okay? But that's what we need, okay? Cool. Now, system dependencies. It means when this little virtual machine is created, what do we want it to do when it starts? Let's do run. As easy as that, okay? But why? The image contains too high vulnerability. I don't care. Okay. apt get update. Okay, so we have to update the insides of this container. And apt get install -y. Okay. Wait a second. Can I do this? Should will I have to research this? Oh, come on. Wait a second. / Control C. Yeah, I don't know how to use /. It's not altgr1. It used to be there. That it's not anymore. Okay, cool. Now, / helps us to have everything like more spaced out. Okay, cool. Now let's do build essential. These are some commands. Okay, lib glib2.0-0. I hope I get this right the first time. It never happens. Lib sm6. This is like the dependencies that this container will have. Okay. It's like all the libraries manually added. Okay. Lib xrender 1. Okay. And lib xext6. And then in the end, rm-rf, which is remove /var /lib/apt/lists everything from the lists. Okay, cool. We have a question. Is this another language for Docker files? It's like YAML, kind of, but with Docker. But no, it's not another language. It's just YAML Docker, so to speak. You can yes and no. Cool. Okay, so work there. This means the work directory that this will be run inside of the container. Okay, what do you want to call it? Pizza. I don't know. Let's call it pizza steak. Why not? Okay. Then we will copy the code. So copy where, here, everything. Okay, that's what this means. Here, everything. Okay. And then install Python. Let's do run pip install -- upgrade pip. Let's have pip upgraded and then run pip install -r requirements.txt. I think I have to disable this. Okay, this is something that I have to do. I'm not sure if it'll work if we don't do it. Okay, tf enable 1 DNN equals, actually 1 DNN opts equals 0. Why neural network stuff? And last but not least, run the command. Okay, let's do Python 3 and we run app.py. Voila! That's basically it. Let's just quick recap. We'll be using Python version 3.9 Slim. We don't need whole Python, just some things from Python. Install some dependencies, remove some things, add a working directory, copy everything, basically requirement.txt. This neural network, okay, let's just do nn stuff. Okay, and run this command. Okay, whenever we tell Docker to run, this is what it's going to read and run for us. Okay, it automates stuff. If not, you have to go into your container and manually do it. It takes too much time. Let's just do it like this. Okay, cool. Now require txt. Okay, we have requirements. What do we need? I think only 5 things. TensorFlow, NumPy, Flask, Pillow. I'm not sure about Pillow, but let's just leave that like this. If you have a desktop Docker, let's try run if there's together. We will learn a no. Why not? Because I've never used Docker in desktop before. We could. I don't have it installed. So yeah, no. If there's time, because I have to explain like the neural network part. But if there's time, probably. But if not, then I don't know. Probably not. Okay. Why do we run cmd for the last line instead of run? Okay, cool. This run applies for everything that you need as bash. Okay. What we needed is to run Python in Python 3. Okay, so it'll use Python 3 and then Python 3 app.py. Okay, so basically we're telling it to use the command Python 3 to run this. If you use run, it'll try to run app.py as app.py. It won't run. You have to manually tell it, hey, use Python to read app.py. Make sense? This is bash. It can run bash easily. It will run with Python app.py. Okay, cool. Let's see, requirements.txt should be good. Last but not least, let's go to my GitHub. Repos. You can find it here. Okay, unit Docker stream. This is the one. Okay, which I'll share in a second or at the end. Okay. What I want is this one. Okay. So this thing over here. This is the binary. Want to see it? Here it is. Okay. Let's see. It's in downloads. Okay, cool. So let's do it as we do it in Windows, because why not? Pizza steak keres, here it is. Let's just move it here. Voila. And okay, tip. Have Copilot open on the side to ask it questions that you are more want more details. It is like efficient note taker, and you get to focus. Yeah, that's good. What is my GitHub? Cool. Wait a second. There it is. That's my GitHub. Cool. But yeah, that's a good tip though. Thanks for the tip. And what is it? What is it? What is it? Yep, that should be good. That should be good. That should be good. Nice. Let's test. So everything's in here. Yes, ls stands for lists. Okay, so I want to see what's inside of my folder. Now, let's just run it. First things first is basically to do. I just forgot the command. Wait a second. I have to look into my GitHub. Was it git image? Wait a second. No, should be here. Let's just do the old. There we go. This is the first one. Where is it? I forgot. It was nope. There we go. Nope. Ah, here it is. Okay, cool. So we say, hey, Mr. Docker, sudo for give me permissions, Docker build -t food classification, where dot means here. So I want you to build this image here. Cross fingers. Usually it doesn't happen at the first time, but let's see if we have no errors. Okay, it's building. It's doing something. Docker is basically creating everything that we are asking it to. I'm just waiting for the error. Like, I'm just waiting for like the big red, like, hey, I don't get what this is. But did I just type everything correctly? I'm not sure. I don't think so. It's doing everything, okay? As you can see, Ale guy, which is the one that asked, see? It's running apt-get update, okay? See that? But run is a command to use bash inside of the container, okay? You can just use run for Python, okay? Cool. Let's see. Everything's going good so far. Okay, well, it did it. Okay, cool. Now, let's see. It's installing everything. Now it's pip, okay? Cool. Nice. First try. Never happens, huh? Cool. Just a little bit more. Here it tells you, like, hey, it takes 15 seconds, 16 seconds. This is a simple container. Bigger images take like minutes sometimes, but yeah, depending on your computer too. Cool, let's see. It downloads stuff. Come on. First try. Okay, yes, I think it's first try. Cool. Okay, nice. Let me just invite this. Cool. Hello. Cool. Let's just wait for it to. Okay, it takes 1 minute. See, so it sometimes first time it like you just have to create the image once. Once you have the image, you can run the container as many times as you like. Okay, if you modify if you modify the code, you have to recreate the image. Okay, just keep in mind that. Okay, cool. Yeah, it worked. Hopefully. Cool. All blues, no reds, no errors for now. So we have an image. Again, the image is like looking at something you want to print before actually printing it. That's what this image looks like. Okay, but that's what it means. Okay, cool. Let's run it. Cool. We'll use sudo docker run -b, okay, and then 5000 colon 5000. What does that mean? Remember, every single computer, including virtual machines, have ports. Okay, containers are no exception. They have ports too. So, we're basically saying port 5000 of my container will be connected directly to port 5000 of my computer. Okay, when we want to talk to this specific container, we'll have to talk through 5000 of our computer. Okay, and food classification is the name that we have. Okay, 3, 2, 1. Errors, give me errors. Okay, so far so good. Huh, cool. Okay, so it's Flask running. Okay, that's how Flask looks. Don't like the warning looks weird, but that's a warning. Okay, remember I told you this thing only listens, doesn't render anything. Let's just take a look at that. See, not found. We had an endpoint, which is classify. See that? This is different. So last time was not found. Like, if we want to look into this, doesn't exist. Like, nothing's there. If you do /classify, method not allowed. Let's just remember why. See? Classify had post. If we have post, it means we won't render anything. We just listen. Okay? This thing just listens. Okay? Cool. Now. Cool. Now, let me think. It's 4:15, 45 minutes to go. I have another stream after this, so I just want like 10 minutes to for my voice and everything. Should be half an hour. Yeah, okay. I'll skip all of the front end part, or like all of the web app part, but basically the web app looks like this. Okay, so here. Oh, by the way. Oh no, that's fine. No, forget it. Okay, so actually you can see here it says get is a method from HTTP. So we have get and post and other two methods. In this case, get is in red because we are not specifically saying that we want to have something rendered. Okay, so get is not allowed. It's a 400 error, which is internal server error. Okay, cool. Now this is good like this. Let's go to desktop. Stream. Oh, what does pizza/steak return? Okay. What specific part of, like, where does pizza/steak is in the code? Doesn't post send data? Okay, that's a good question. Post sends, but also listens. Okay, so post is only for sending and listening, but not for rendering. Okay. Yeah. Okay. Yeah. So basically, what I mean with listening is it'll be trying to receive data and sending data. Okay, that's what I mean with listening. It's just, you can imagine it as someone sitting on a desk and just waiting for something to arrive, compute, and then send like the it's like a stamp. So it's just stamps and sends it, stamps and sends it. So yeah, that's what it does. We're getting a yes. Give me a second. Cool. Now, I won't go into the web app part because it takes a lot of time. We won't code it. I'll just show it to you. It's on my GitHub, but let's just take a look at it. ls. No. We have to go to unit. 2, was it? Yeah, cool. Nice. So let's see. Thank you, Visual Studio, for opening again. Cool. So we have another app.py here. Okay. Okay. Cool. Now you can see it here. Here we have method get and post. Post is purely for data. Okay. So let's say you are trying to log in to somewhere, facebook.com. You'll be sending your username and password. When you click on login, there's a post method that HTTP listens to and sends your data to Meta. Okay? Same thing with every single input output in web apps. Okay? Make sense? Get is when you, it's a method that is called when you wanna render something on a web app. Okay? So in this case, we don't have get. So it doesn't render anything. And you can double check here. We can do, what was it? This thing over here. /classify. See, it says method not allowed. This means I'm trying to access classify. I wanted to render something. It says this method is not allowed for the requested URL because we're explicitly telling it not to allow it. If you see, there is no get here. It's only post. Okay? Now, on the contrary, this part over here, which I wanted to program, but I took a little bit more time, we have the get. And this get, actually it says, hey, if the request, like if the method is post, it means if we are sending like data from here, then in the end, we will be sending stuff to our API, which is here, basically. Look, API URL. And this API URL is the same one as this one. See? It's a little bit like small, but you can see it's the same one. It means we don't need it to render stuff, just listen or basically wait for data to arrive. This part over here is the visual part, okay? This is the other side of the web app, okay? If you can see here, it says render template, index.html, file name none. In this case, you know, just ignore this. But in this case, index.html. This index is here, and this is the HTML file. Okay, let's take a look at it. Like let's see how it works. So first of all, we source env bin activate. If you don't know what this does, by the way, here Ale guy said something. I believe when you try to go to a web page from a browser, remaking a get request, which renders basically, yeah, get is everything that has to do with front end. Posts is everything that has to do with, not everything, but it has to do with backend. It only sends data. It doesn't affect you visually. Okay, so your web page visually won't get affected. Okay, the code is on GitHub yet, right? Yeah, no, this one no. Like the Docker side, yes. This front end, no. I'll upload it once after our stream. Okay, so what does this mean? Source env bin activate. So whenever you're using Python, you may use lots of libraries. Some of them are already downloaded for you when you download Python. Some others are not. In this case, Flask. TensorFlow is one of them too. What we all recommend is you have to create a virtual environment in Python. Okay? How do you do that? Well, that's easy. You do py, in this case, py dash Python 3 for Ubuntu. If you are using Windows, it's py, okay? But in this case, Python 3 dash m, okay? V, like this, and then env. Okay, let me just do this so it looks better. There we go. Python 3 dash m, v, and then the name of your environment. In my case, I always love to name them env. It's easy. You know, you'll create a folder like this one, and see you have a lot of things here. What this means is every single library that you'll use will not be downloaded in your source Python inside of your computer. It's downloaded in a safe environment that if you want to get rid of it, it's easy. Okay, cool. Now, wait a second, let's do this. I won't hit enter because it'll rewrite my whole thing, but cool. Now, let's do Flask, run. 3, 2, 1. Ooh, what happened? Let's just read the error. Port 5000 is in use by another program. Who's using 5000? Aha. See that? It means even if it's in containers, we connected it here. Remember? Sudo docker run 5000 5000. It means this computer's port 5000 is already being taken by this container. Don't believe me? Control C, container goes out. Cool, container is out. Oh shoot, sorry. Let's just do this. Container is out. Let's do it again. Ooh, it works. See this? 5000. Okay, cool. Let's take a look at this. Ah, see? I hope I answered the get and post method question. See this? We can see something. In this case, the same IP, same port. We have to fix that. But see this? There is something. Now, let's test the post method without API. Choose file, send the pizza, 3, 2, 1, upload. Ooh, what happened? See? Error in processing. Where is that error? You can see here it says post 5000, 404. 404 is internal server error. 5000 is my side of the error. Okay? 200 is okay. 100 is message. 300 is redirection. Again, if you get a 100 error or 100, let's call it error, okay? In HTTP, in this case we got 200, but if it's 100, it's purely message. You got a message from HTTP. 200s, 220, 240, whatever that has to do with 200s, okay. 300s, redirection. It could be from HTTP to HTTPS. It could be from facebook.com to facebook/hello.com, whatever. 400s means internal server error. It's not on your side, it's on server side. 500, it's on your side. Okay, so it's not like your problem. Okay, basically. Cool. Now, Control C. We don't need this, or not right now. Let's run Docker again. Okay, you can see we can run Docker as many times as we like, as long as we don't recreate the image. Okay, so if you recreate the image, you have to wait like 5 minutes, but in this case, we don't have to. Okay, cool. This is running in 5000. Let's fix that. So we can do export. Okay, we export Flask. Run port equals 8000. 8000 is not a bad port. Let's just use 8000. Voila. Something happened. No errors. That's a good thing. A little bit of water. Well, it's not water. It's just, it's horrible. Don't buy it. I won't say the brand. It's just bad. Okay. And will it run? Will it not run? It ran. Okay. We exported. We specifically told Flask to run in 8000. Okay. It means another port separately. Okay. Cool. So your understanding, Aligai, is that when you do docker run, it calls CMD without doing all the run steps again. Yes, but run uses bash. Okay. CMD, you can use different commands, Python, Vim, something like that, but without using bash. Make sense? I hope it makes sense. But yeah, basically that's it. I'm okay. Cool. Hi. Cool. This is running. Let's take a look at this. Ah, cool. You can see here, it says 127.0.0.1, the same IP that we have here, but after the colon, it's different. Okay? After the colon, we have 8,000. It means it's running on a different port. Same network, different port. Same hotel, different floor. Cool? Nice. Different room. Yeah. Cool. Let's see if it works. Let's see a pizza. Cross fingers. 3, 2, 1. Ooh. 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 Huh? Got it? Huh? Wait a second. Wait. Huh? Huh? Got it? Yeah. I know. It's awesome. I know. Don't believe me. Steak. Okay? Steak? 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 Now, I know what you're saying. Bully. The names of the files are steak and pizza. That's easy. Let's try it with something else. Pizza. Domino's. Domino's is not that bad. I won't dox myself anymore. Cool. Let's get, I don't know, this one. Save image as. Let's put it in desktop. Streams, food classifier, test images. Not. Let's do. Oh, it's a web. Wait a second. No, not that. Let's see. This one. Is this an image? I hope. Yes. Let's do. I don't know. Steak 2. Okay. Just to confuse the AI, because I know you don't believe me. So let's do this. Where? Here, desktop, streams, food classifier, test images. Hey, steak 2, huh? Choose file. Steak 2. It's a beta, huh? I hope the AI doesn't get it wrong. If it gets it wrong, it's gonna be embarrassing. It's not. I promise. It's a neural network. Okay. No, shoot. Pizza. No, it's steak 2. Upload. Whew, it got it. See? Voila. So you have, or we have. You can see there was something done here. It took 1 second. Yep. And then it returns something that this app listened to. Let's take a look at that app because we didn't see it that much. Cool. So this app is connected to our URL. This URL here, remember, it didn't render anything. It was just something waiting for data to come. Okay? It's basically an API. Basically folder stuff, just, we have here uploads. Here we have steak 2, which shouldn't be here. It should be the other side, but we got it here too. Okay? This method allows get, which is the visual side, and the post, which is the data side. Okay? So we have the two methods here. If we have something which is post activates whenever we click on this button here. Okay? Whenever this is clicked, post is activated. If I click here, post is not activated. If I click here, it is. Okay? Cool. Now, if image not in not this one, should be this one. Okay? If file not in requested file, no image uploaded, and we return a 400. Okay, which means internal server error. Okay, cool. We get the JSON here. You can see here response equals requested post. Our URL, which is the API, get me something called image. I will open it as a file. Okay, if it's a 200, which means everything's okay. We get the JSON, which is the response. we get, hey, give me the food. Why food? Ah, food. Okay. If we change this into another, to, I don't know, apple, won't work. Okay, because it's a mismatch. Okay, you have to do food, food. Okay, and it renders the same thing, but now, you know, just this is just pretty fine stuff. Okay, but the core of this is basically here. We connect to the URL, which is here. API URL. We post here our image, and we open the image that was sent, which is here. Okay, cool. Makes sense? Questions? Let's see if you have some questions. In the meantime, I'll drink this horrible, horrible, horrible drink. I won't show it though. Let's see. And it's a big can though. That's a horrible. It's whenever it's a big can and it's not that good, it's like, but yeah, not that bad though. But yeah, could have been better. Just because it says gamer, but yeah, marketing got me. It always does. Cool. Questions? So, okay, cool. Ah, nice. That's a good question. So, you got your app here. It works. What you need first is a DNS, which is a domain name, or like, yeah. So, you need a domain name. Let's call it alleguy.com. Okay? Then you need a server. Somewhere in the world, could be your home, could be a droplet, which is a server from OpenOcean, was it? OpenOcean? Was it OpenOcean? Wait a second. Names today are not my forte. Droplets. DigitalOcean. Okay, so from DigitalOcean, okay, you have virtual machines that can connect to the internet. Yeah, that's it. And that's your server. From there, what you can do is add a domain name, which usually costs. It doesn't cost a lot, but it could be alleguy.dev. Puts on shades, yeah. And then basically inside of that server, do what we did, but instead of calling it in your Flask, instead of calling it like this, you have to connect. It has to be 480. I don't remember. Wait a second. HTTPS port. Wait a second. What's the port start on? 443. 8080 is HTTP. 443. Okay, yeah. So 443, port 443 has to be connected to this Flask in order for you to access it from outside. Okay, you have to tweak a little bit there, but if you get into, if you get into the SRE track, that's what we're going to do. Create a droplet, do some stuff to it, and have a server up and running with your name on it. Okay? That's basically what you have to do. You have 80% of the things. You just have to connect some stuff for it to be live. Okay? Cool. There are no dumb questions. This image is different from Docker image. Yes. Okay, so this, or yeah, all of the visual, like this part of it, it's not in Docker. It's outside of Docker. Okay, so in the end, you have Docker running in 5,000, this thing running in 8,000. It means it's totally separate from Docker, but it can talk to each other. Okay, you can add that part, like this part over here, inside of a Docker container. That would be the easy thing because it's portable. You can add it in your Raspberry, in your Mac, in your Windows. I'm not sure. Whatever you want to do. But it's portable. Now you can do it. It's like magic. But yeah. So you can use, oh yeah, definitely. You can use Heroku, Vercel. Yeah, definitely you can use those things. I just went for the more, how can I say it? Like hardware, I don't know. I just went for the, how can I say it? Like more low level to it. But yeah, you definitely can, if you have a server, you can use Heroku. Yeah, definitely. Cool. Question. So follow-up question. Yes, if I already have something up, Allegai, okay, could I deploy the Flask app specifically to the Allegai endpoint? Yes. If you don't have, if you have nothing in /app, yes. If you have something in app, it would clash as it clashed before with us. Like 5,000 is being used by something else. Okay, but you can definitely do that. But you have to tweak a little bit some things to connect. But yeah. Thank you. I know you got me, and yeah, low level. but yeah, that's the magic of Docker. It's like you can use it wherever you want, whenever you want, and it's just like you can clone my GitHub repo. I'll tweak it today. You can clone it wherever you want, and it'll work as it worked with me. Okay, that's the cool thing about it. It's magical. Okay, cool. I know it's very, yeah, cool. Nice. So I know you're you want to see like the AI part. Let's just take a look at it. Let me just turn this off. Okay, and yep, cool. Okay, I see that there are no more questions about Docker, so let's just go into the AI part pretty quick. That's really cool. I've been waiting to deploy something with Docker for a while. You can do this. The limit is your imagination. You could like use Docker whenever you need to compute something. Okay, if you need to compute something, like in this case, then you can actually connect. What I wanted to do, the original idea for this stream that didn't happen, was my Raspberry was going to host this API. The thing is, connecting my Raspberry into my other like screen was a little bit too funky, and I have a lot of cables, so I didn't do it. But you can definitely do it. You can do IoT stuff. You can do whatever you want. Docker is really cool. But yeah, cool, nice. So let me just get rid of this. Wait a second. Bye. Cool, I'm here. Okay, let me just close this for now. You go there, thanks. You here. Ah, good. Now, not this one, this one. Okay, what? Wait a second. Okay, F11, there we go. I'll just get out of this. This won't affect. No, cool, thank you. Nice, okay, so. What? Huh, there we go. Okay, cool. So, let's go into the other part. To automate running of container stuff. Yeah, yep. Cool, okay, so this is Colab. What the heck is Colab? So Colab is notebooks, like Python notebooks, which Jupyter notebooks basically, hosted by Google Colab or Google. It's cool because you can connect to different hardware. Let's see if there's a GPU available. By the way, this is free, so yeah. You have a paid, if you want to like have more GPU power, more RAM, more stuff to it, you pay a little bit more, but in this case it's all free. Okay, it won't connect, come on. Okay, you can see we have T4 GPUs, a CPU, and a TPU is a tensor processing unit. It processes tensors. If you don't know what a tensor is like a matrix of matrices, basically. You know, let's leave it there. But yeah, cool. Okay, we have a T4. We won't run this, okay? I just want to show you where the neural network came from and our special number 224 by 224. Okay, cool. By the way, shout outs to Mr. Deeberg. He has a great deep learning course on Udemy. Okay, it's called Zero to Mastery TensorFlow. I learned from them, so definitely check them out. Okay, cool. Here is our data, okay, or his data basically. We imported stuff here. The important thing is this is TensorFlow. I'm not sure who asked, but this is how TensorFlow looks. Okay, so this is Python basically, but where is it? Where is it? Ah, cool. Okay, so we start with see. So basically, every single image from this dataset will be changed to 224 by 224. So you can see here the first layer of our neural network, which Let me try to draw it with, there we go. Neural networks have layers, okay? We have 1, 2, 3, in this case 4. They connect like this. This is horrible. Wait a second. 1, 2 should be easier. They all connect like this, like this. This should be connected here. This should be connected here. This one here. This one here. Let's just assume there's a final neuron here, and voila, a happy face here. Okay, cool. So this is the input layer. This will tell you how many things you can add to it. Okay, in this case, this should accept an image of 2 by 2. It has only 4 neurons. If we needed, or if we wanted to accept images of bigger dimensions, we need 2 to 4 in this case, times 2 to 4 neurons. Input shape 2 to 4 by 2 to 4. See that? Okay, so we are expecting this input. If we added something different, the neural network tells you, I'm expecting 2 to 4 by 2 to 4, because if not, I won't do anything. That's how they are. Yes. Okay, cool. Some math here that I won't explain in this stream, but here you have something interesting. Sigmoid. Sigmoid is a function that looks like this. There we go. This is the function sigmoid. Okay, it goes from 0 to 1, and it helps you as a final neuron. Okay, in the end, you can see it's in the end output layer, which is the last layer. It's either 0 or 1. So it gives us a range of numbers between 0 and 1. Okay. Remember that we had on our code, or inside of our code, if the prediction is less than or equal to 0.5, it was beta, I think. This is what it does. This is the output. Okay, and it's just 1 unit. Why? We just need 1 neuron because it'll activate slightly if it's a stake, or a lot if it's a beta. Okay, cool, nice. Now this is more math stuff. Important thing is that this is another neural network. Someone asked, what is TensorFlow? Well, this is basically TensorFlow. We're creating neural networks from scratch. You can just type them down, blah, blah, blah. You have it here. It's really, really easy to use, really cool to use, really fun if you love math. Yeah. Here you have, this is not important, but this is the accuracy. We have 2 different neural networks. One has better accuracy than the other. You can see the architecture is different. We had this one, and we had this one here, okay, which is slightly larger. Okay, in this case we have augmented training data. Augmentation means blurring an image, flipping it. So for you as a human being, it's easy. You just say, hey, it's the pizza, just flip it, and that's it. For an AI, it's a completely different story. Okay, so it's not, for an AI, it's not the same having this mouse. Oh, come on. This, great. I don't know, this thing. Okay, it's not the same having this pen like this as having it like this. You're a human and you're really smart. AI is not smart. So we have to train it to say, hey, this is the same thing as this. It just looks different. Okay, cool, nice. That's augmentation. Okay, and actually you can see here it says, here it says, it's sharing the image. It means it's like sharing the image from the outside, so it looks smaller, bigger. Horizontal flip too. So you just do this. It does a lot of things. That's what TensorFlow does. It's really cool. This is how the neural network looks like. So it's a convolutional network. We have to use this one for images. Okay. See this input shape none. 2 to 4 by 2 to 4 by 3. What does this none mean? Again, batch. Okay, so if we just added 2 to 4 by 2 to 4 by 3, neural network tells you, hey, I'm missing something. Even if it says none, I need to have some space here, and that's for the batch. And batch again is like you're a group of images. Okay, so you have to send them, because we train them with batches. We have to send them an image with a batch. It's just a dimension that's there floating. It doesn't do anything, but it doesn't confuse the neural network. Okay, in this case, you can see here we have batch of where is it? Should be here. There you go. Batch size 32. So we added 32 images per iteration to the neural network. Okay, makes sense? I hope it makes sense. It's a little bit confusing, I know, but that's how it works. And in the end, we have something which is a dense, which is a single neuron that computes something. It has an output of 1, and the input shape, this is all the neurons that were behind it. Okay, so we had 29,000 neurons behind it. Okay, yeah, it's big. Just 1 output. If you wanted to tell you, hey, number 1 is pizza, number 2 is steak, number 3 is hot dog, then we cannot use sigmoid, because sigmoid gives you range from 0 to 1. We need something called ReLU or softmax, and that'll give you range of numbers. Okay, yes, this is a CNN. This is a convolutional neural network. Okay, you can see it here because we have max pooling, we have a convolutional network here, max pooling. Okay, I won't dive into the details of what this do, but yeah, it's a CNN basically. And in the end, you can see steak. See, in the end, we see shape of the image. We took an image of steak, and the image was 512 by 384. We had to reshape it. There's a 1. See that? There's a 1. That's the batch number that we have to add. If you don't add that, neural network goes crazy. It just tells you like, I don't get what you're saying. Goodbye. Voilà. That's basically it. And in the end, this is what you do. You can save the model as pizza steak keres. This is the binary that I downloaded, the binary that I used. And when I have the GitHub, I'll just let you know, this is the binary that you can use. It'll work the same thing with you as with me. Docker, it doesn't matter if you have a different computer, the binary is the binary, okay? Cool, that's it. Was this fun? I hope it was fun. Let's just do a close-up here. Remove, cool, fun, yes. So, promise, by the way, Ale guy, I have here your posted. I have another stream. After the stream, I'll message you. and yeah, you have my GitHub there. I will add this to the repo, okay? So you can have the whole repo. You can run this wherever you want. It's Docker and TensorFlow. But yeah, I hope you had fun. One last thing is, where is it? Could you please answer this survey? Don't worry. I saw that. I was like, yeah, I'll answer. I'm just horrible. Even with my girlfriend, she's like, you forgot to message me, and I was like, oh shit. Just ping me 10 times. Yep, I'll do that. Okay, give me a second. I'll need. Give me 1 second. Could you please answer or give us feedback? Give me feedback here. Please. Cool. Just send me the feedback there. That'd be great. What is the new Udemy class you mentioned? Ooh, it's called Zero to Mastery. Literally, 0 with Z, 0 to Mastery. They have about Python, TensorFlow, which is the one that I learned from. They have a couple more. I think they have a C++ one. It's a great community. I definitely would tell you to check it out. It's great. It's on Udemy. It's at your own pace. And yeah, like not sponsored, not anything. I just learned from them, and you know, my AI love came from Zero to Mastery. So yeah, highly recommend you to go and check them out. But yeah, again, Zero. Let's just write down Zero to Mastery TensorFlow course. Cool. There it is. Nice. Cool. So I'll be hosting the next stream. So I'll go get some water, prepare the other stream. So I'll end this stream a little bit earlier and start probably the other one 5 minutes later, just so my voice can get a little bit, better. But yeah, thank you all for joining. Just in case for anyone who has just joined, this is the Docker one. Yes. There you go. Could you please, just register there? And yeah, see you in 15-ish minutes. Okay. It'll be about ROS, which is a robotics operating system. I'm a robotics engineer, by the way. Hey, I didn't do the intro. My name is Bully. I was just too nervous. Quick intro. My name is Charbel, or I'm called Bully. I'm a robotics engineer. I also am a pod leader and a streamer. So happy to be here. And yeah, so I'll be talking about ROS in 15 minutes. So yeah, I'd be happy to see you there. And yeah, so see you in 15 minutes.